All right, lesson 5.1 is we're getting into this next unit, which is about parallelograms and actually quadrilaterals, any four-sided things. So today specifically, though, is parallelograms and trapezoids, their properties. Okay, so let's just start out by drawing a parallelogram. Parallelogram has opposite sides that are parallel. So I made 4 centimeters there, and I'll try to make it exactly parallel and make it also 4 centimeters, and then make these two sides, they happen to come out to about 2 centimeters, but you can see the big thing is these are parallel, so these parallel and then these are parallel. Okay, so parallelogram, the main property, the main definition, opposite sides are parallel. Okay, it's 4 sides, obviously, opposite sides are parallel. Some other things you notice, opposite sides are equal or congruent, and also these opposite angles. On your homework you'll have to measure out these angles, and you'll notice opposite angles are congruent. I don't have a protractor here actually, but these angles should be the same. These angles should be exactly the same. You'll have to measure those in your homework. Okay, we'll go on to a rhombus. It's actually a parallelogram. Parallelogram with all sides congruent. You could say equilateral, right? We said that before with the triangles. Equilateral. All the sides are the same. So, let's say I make them all 4 centimeters. I'm going to make these two sides first. 4 centimeters, and I'm going to try to make this top side exactly parallel to the bottom. And if I did it accurately, they all should measure 4 centimeters. It is still a parallelogram, okay? Still got these are parallel. It's just now they're also equal. Okay, so it has all these properties. Opposite sides are equal, opposite angles are equal, but just now all the sides are equal. The other type of parallelogram is a rectangle, which is pretty easy to draw. Let's go 4 centimeters, and then you guys probably know a rectangle has 90 degrees. I'll go 2 centimeters like that with a 90. But you notice it still is a parallelogram. This top is parallel to the bottom, and this right side is parallel to the left side. But the big definition is this is rectangle. Parallelogram with all angles equal or congruent. In other words, equiangular. Okay, in other words, they're all 90 degrees. I mean, really 90 degrees, right? If they're all equal, they got to be 90s. Okay, it is still a parallelogram though, like this and like this. Okay, so the big idea, these are all parallelograms. These are just 2 special types, and the last special type is, you guys know, a square. Let's make each side 3 centimeters. So square is actually a parallelogram that is equal sides and equal angles, right? Okay, we say parallelogram with congruent sides and angles. Okay, it's equilateral and it's equiangular, so all 90s, and then all these sides were the same. I made them all 3 centimeters. Okay, so that's pretty easy. The only other thing is trapezoids here. Let's look at a couple of examples of trapezoid. So a trapezoid is not a parallelogram. Trapezoid has only two sides parallel. Instead of, instead of having two sides and two sides, it just has two sides. Okay, it only has one pair. Okay, so if I make, and they don't have to be the same length in this case. So say I make the bottom side like 6, and I try to make this top side parallel, but the top's maybe only like 3. Okay, try to make it parallel though. And if I connect those, that's a trapezoid. Okay, 6 centimeters, 3 centimeters. These are parallel. There's other properties that you'll look at in your assignment, but that's a big thing. Those are parallel. And then the last thing I want to show you is isosceles trapezoid. It's a trapezoid that has these sides are also the same. Okay, your bases are not the same, we say, but the left and right, or the two sides, are equal. Okay, so let's draw it out there. This one looks almost like it's isosceles, but let's try to for sure make it isosceles here. So I'll make the bottom 6. And the key is you got to make these two angles the same. Okay, if I had a protractor right here, I could do it better, but so in other words, if this is 60 degrees, you got to make sure this is also 60 degrees over here. Okay, I'm eyeballing it. But on your homework, you guys will need to use a protractor to make it accurate. I'm going to bring this in just a little bit. That looks pretty close. Okay, so you notice these two sides are exactly the same, and these two sides are not the same, but they're parallel. Okay, so basically it has two congruent sides, which I'm talking about that side and that side. Okay, and it has two parallel sides and then two congruent sides. That's isosceles trapezoid. You'll notice some other properties. These base angles are actually equal, like I said. We call those base angles. These top angles, which are also base angles, are equal. So these are called base angles. These sides equal. There's some other properties there. And then the very last thing I want to tell you is it'll say on your homework to draw the diagonals. On a shape, the diagonals go to connect opposite corners, or opposite vertices, we could say. Okay, connect opposite vertices. So, you got all these different shapes, whatever. Say it's a parallelogram. I'm just going to kind of roughly draw one out. If I say diagonals, what I'm talking about is they connect like this corner to this corner. That's a diagonal, we say. Okay, so you'd measure these and kind of notice some things about it. Like in this case, are these diagonals the same length? Well, they're not actually. This one's a little longer and this one's a little shorter. So that's something we're going to look at going forward, is the length of these diagonals. That one's shorter. This one's actually longer. But diagonals are these segments. If I label them, it'd be like segment AC, and then it'd be I guess this other one here, segment BD, are the diagonals. Okay, I think that's everything you need to know there, guys. Good luck.